Hi, I'm Kelly Johnson. I'm from the Cognitive Science program, and today I'm going to be talking about improving medicine using math and psychology. In the 1980s, when HIV infections were peaking, a group of 22 blood donors in Florida were told that their blood tested positive for HIV. And tragically, 7 of them committed suicide. Later on, it was pointed out that a few of them might not have even had HIV, but weren't aware that false positives were possible. In reality, given that someone gets a positive HIV test, the probability that they actually have it can be as low as 50%. If this is surprising to you, you're not alone. So how can this be? Well, what we need to know is how common is HIV? Because the percent of people who have a disease, what we call the base rate, is critical to interpreting the test result. So HIV is rare, meaning it has a low base rate and relatively few people have it. Those people are represented by the small red circle here. Most people don't have HIV and are represented by the large blue circle here. And since there are so many of these people, even if only a fraction of a percent get a false positive, that actually ends up being a lot of people. So this means that when we look at all of the people who got a positive test, those in the dotted green circle here, only about half of them actually belong to the group of people who have HIV. So properly incorporating the base rate is difficult for people. So psychologists have been studying this for a long time. And there's a lot of work showing that ignoring the base rate causes medical experts, including physicians, to miscalculate the probability that someone has a disease by a lot. Studies have shown that many physicians don't even acknowledge any possibility of a false positive HIV test. And there's also a lot of work on this in cancer screening, and currently a lot of discussion on how this relates to interpreting tests for COVID-19. So I wanted to figure out how people process these types of problems. And I came to this idea that maybe people are placing less weight on the base rates because they view them as imprecise or unreliable. So I did some experiments, and instead of just presenting the base rate as a number by itself, I added information about how that data was collected. And I found that when the base rate was described as being really accurate, people used it more. This is really interesting because according to all the other theories in psychology, people ignore base rates altogether. However, we found that people do use base rates, they just need the right information to use them properly. So now I'm working with a range of healthcare experts to figure out how different types of information will affect how they use base rates. And what I find is that these experts don't ignore base rates. However, the information that comes along with that base rate, like how it was calculated, will affect how they use it. So ultimately, my goal is to improve the accuracy of diagnoses. And to do this, we need to understand how experts process different pieces of data so we can provide them with the information that they need to make the best judgments and the best diagnoses possible. Thank you.